Good, good morning, everyone. How are you? My students of Secondary 1, welcome. Today we'll discuss and talk about the quantitative chemistry, which is started in the previous week. We take how to write the chemical formula in all types of compounds, ionic compounds, covalent compounds, and acids in both types, oxygenated acids or halogenated acids. Then we started to write how to write the chemical equation and how to balance the chemical equation, and for sure discuss what is the importance of writing chemical equation. Okay. To remember the balancing of chemical equation, we can see this video.
Sulfur, I have 8. Oxygen, I have 2 on the product side. How to balance chemical equations in 5 easy steps. Step 1. Count the atoms on each side of the equation. Let's count each type of atom. Sulfur, I have 8. Oxygen, I have 2. On the product side, sulfur, I have 1. And oxygen, I have 2. Note that if there's nothing after an element, we assume that to be 1. And that's it. We're done with the first step. Smooth. The big rule for balancing equations is that we can only change the coefficients. Those are the numbers in front of the atoms. The numbers after the atoms, the subscripts, cannot be changed. So let's balance this equation by changing the coefficients. If there's no coefficient written, we assume that it's 1. So right now there's a 1 in front of each of these terms. We can see that we have 2 oxygens on each side of the equation. So the oxygens are fine, but the sulfur atoms, we have 8 on the left side, the reactants, and only 1 on the right. Well, to fix that, I can change the coefficient in front of the sulfur on the right and make that an 8. So if I put an 8 here, that means 8 times the 1 sulfur. That'll give me 8 sulfurs. And now my sulfurs on both sides are 8. But this 8 here is also times the 2 oxygens. And that gives me 16 oxygens. So I've fixed the sulfurs, but the oxygens aren't balanced. I can change the coefficient here, though, to 8, because 8 times 2 equals 16. So now I have 8 sulfurs on each side, and I have 16 oxygens on each side of the equation. This equation is balanced. Step 3, so you don't forget, only change the coefficients. Let's try another problem. So in this equation we have 2 hydrogens, 2 oxygens, over here 2 hydrogens, and 1 oxygen. How about, let's see, I'll put a 2 right here. So 2 times 2, that gives me 4 hydrogens, but 2 times the 1, that'll give me 2 oxygens. So my oxygens are balanced now, but my hydrogens are messed up. What I can do over here is put a 2 in front of hydrogen, and now 2 times 2, that'll give me 4. And now the atoms on each side of the equation are the same. This equation's balanced. Sometimes we'll have equations that look downright scary. Yikes. But if we have a polyatomic ion on both sides, like the SO4 or the NO3, then we can consider that ion to be just one thing. Let's see how that works. So here's the equation, and I've done my accounting below. You can see I have 1 calcium here, 1 calcium over here, and then I wrote the entire SO4 as one thing. And I have 1 of those here, and over here I have 1 SO4, NAs, 1, 2 NAs on this side, and over here 1 NO3, and I have 1 NO3, but that 2 on the outside means I have 2 of them. So I have 2 NO3s. So if I put the coefficient of 2 right here, that means I'll have 1 times 2, 2 NAs, but this 2 also multiplies across, so 1 times 2 for the NO3s, that gives me 2, and now everything is balanced. So by treating those polyatomic ions as just one thing, it makes it a pretty simple equation to balance. Let's wrap up with one that sometimes gives people problems. So we can see we have 1 carbon, 4 hydrogens and 2 oxygens. Easy. Over here we have 1 carbon, and then we have 2 oxygens, and then we have 2 hydrogens. But be careful. We have to count this oxygen over here as well. So we have 2 plus 1. That'll give us 3 total oxygens. I'll start by balancing the hydrogens. If I put a 2 in front of this hydrogen, 2 times 2, that'll give me 4, and that'll fix the hydrogens. But now I have 2 oxygens plus 2 times 1, 2 oxygens. That gives me a total of 4 oxygens. But that's good, because now if I put a 2 right here and change this coefficient, 2 times 2 equals 4, and now everything is balanced. This video has given you the basics for balancing equations, but you've got to practice to gain speed and expertise. The more you practice, the easier it becomes. This is Dr. B, and thanks for watching.
As we see in this video, we follow some steps to write a balanced chemical equation simply and correctly. After the balancing of chemical equations, we will discuss the types of chemical equations to be easy for us to detect what is the product of each chemical equation and predict the product simply. Let us show or watch this video.
If, however, the classifying chemical reactions with the Flintstones. If Fred were to go to a dance and he were to meet Wilma, Fred and Wilma would combine together and form the Flintstones. This is called synthesis. When substance A is added to substance B and you get a combined compound of AB, you have created synthesis, similar to when hydrogen and oxygen bond together to form the molecule water, the synthesis of water. If, however, the Flintstones were together and they got a divorce, so that Fred was on his own and Wilma were on her own, then you have decomposition. A compound breaks down into its component parts. AB yields A plus B. This happens in the decomposition of potassium chlorate, when KClO3 breaks down into KCl, potassium chloride, and oxygen gas. If, however, the Flintstones went to a dance and they met up with Betty, and when Betty showed up, she ended up with Fred, leaving Wilma by herself, we would call this single replacement. We are replacing one part of the pair. So AB plus C gives off AC plus B. We are replacing one part of the compound. This is called single replacement, and this happens when silver nitrate combines with copper to create copper nitrate and release silver. And our last type of chemical reaction is a double replacement. That's if the Flintstones went to that same dance, and there they met the Rubbles. And while they were dancing, Fred ended up with Betty, while Barney ended up with Wilma. In this case, we are exchanging two partners, this being double replacement. AB compound breaks down along with CD compound, which breaks down, and you end up with compounds AD plus CB. An example of this would be a double replacement reaction where potassium nitrate combines with magnesium chloride and ends up being magnesium nitrate plus potassium chloride. This is classification of chemical reactions, and thank you to the Flintstones.
How to balance
As we watched in this video, there are four types of chemical reaction. The first type called synthesis, the second called decomposition, third is single replacement, and the fourth are double replacement. This is four types. It is very important to know it to predict the product of any chemical equation from the reactant. So now we will discuss the type of ionic equation. What is the meaning of ionic equations and how to write the net ionic equation. We have two types of ionic equations. The first one called neutralization equation, and the second one called precipitation equation. Neutralization equations, this is for the reaction of acid and base to produce salt and water. So the net ionic equation represent the formation of water from hydrogen ion and hydroxyl ion. While the precipitation equation, this means the formation of insoluble salt, water insoluble salt, due to the reaction of two solutions. And how to write the net ionic equation for this type of equations, precipitation, we will see more details in this video.
Hi, in this video, we are going to learn to write ionic equations from chemical equations. Let's look at this chemical equation. The ones in the brackets are state symbols. The state symbol AQ means the substance is in aqueous state. This means the substance is dissolved in water to form solution. L means liquid state. If you have G, it means gaseous state. S means solid state. Only the substances in aqueous state can be split them into ions. Hence, for HCl, we split it into hydrogen ion and chloride ion. For NaOH, into sodium ion and hydroxide ion. For NaCl, into sodium ion and chloride ion. For H2O, L states, don't separate it. You can see that some ions remain the same before and after the reaction. The sodium ion and chloride ion. These are called spectator ions and can be cancelled out. So we cancel out sodium ion and chloride ion on both sides. We get the net ionic equation. Let's look at another chemical equation. The equation must be balanced before you start with the ionic equation. For sodium sulfate, we separate it into ions since it is in the aqueous state. Notice that there's a 2 in the formula. This means there are 2 sodium ions and 1 sulfate ion. For lead-2 nitrates, split it into lead-2 ion and 2 nitrates ion. Lead-2 sulfate is in solid state. Leave it as it is. There's a 2 in front of sodium nitrates. This means we separate it into 2 sodium ions and 2 nitrates ions. We cancel out the ions that are same on both sides. And we get the next ionic equation.
As we watched in this video, how to analyze the ionic equation to its ions enter in the chemical reaction, and how to um, cancel the common ions between the product and reactant to find finally the net ionic equation in the case of neutralization reaction or precipitation reaction. This is the end of preparing or preparatory lesson to introduce in the mole and how to use the mole in many calculations in the chemistry. Now we will discuss the concept of mole. What is the meaning of mole and what is the importance of mole? Firstly, we will remember what is the meaning of atom and what is the meaning of molecule. As written here, a molecule is the smallest particle in a chemical element or compound that has the chemical properties of that element or compound and exists alone, while atom is the smallest building unit of matter which takes part in a chemical reaction. Okay, now we will discuss or watch, a video to illustrate the meaning of mole and its
Go to a
importance.
supermarket. We always buy things using standard value. When we go to a supermarket, we always buy things using standard values. In other words, we always take 1 kilogram of rice or 200 milliliters of fruit juice. Fruits are sometimes counted using the unit dozen. 1 dozen means 12 of something. These are terms used in everyday life. But what if I want to measure something in terms of the number of tiny particles present in it? Let me explain this in detail. Looking at this pure gold, can you tell me how many gold atoms are present in this? Or wait, looking at this glass of water, can you tell me how many water molecules are present in it? You will probably say that it's practically impossible to calculate the number of atoms or molecules in these examples. But astonishingly, chemistry has an answer to this as well. That brings us to the concept of mole. What does it mean? It's very easy. 1 mole of anything has 6.022 times 10 raised to 23 atoms or molecules or particles present inside it. Isn't this number huge? If I have to write down the zeros, this is how big the number will look. 1 mole of anything has these many particles. Now let's say we take a substance which has 3 times the number of particles here. Then we say that this is 3 moles of this substance. And what if we have a substance which has 8 times the number of particles here? That's correct. It will be 8 moles of that substance. That's the basic concept of a mole of any substance. Let's see if you've understood the concept well. Now here's 1 mole of this pure gold. How many atoms does it have? Yes, as it's 1 mole, it will have 6.02 times 10 raised to 23 atoms in it. Similarly, 1 mole of pure water will have 6.022 times 10 raised to 23 water molecules inside it. So is this how we define 1 mole? 6.022 times 10 raised to 23 atoms or molecules or particles? Well, that's the simplest way to understand it. That means if we take, for example, a bag containing 6.022 times 10 raised to 23 hydrogen atoms, then can we say it's 1 mole of hydrogen? Yes, that's right. Similarly, 6.022 times 10 raised to 23 molecules of any compound like copper sulfate is 1 mole of copper sulfate. Simple, isn't it? Wait. We have just understood the concept of mole in simple words. But we are yet to take a look at the scientific definition of 1 mole. And what's this number we refer to? Does it have a special name? Watch our next video to know more.
This is a simple video illustrate the meaning of mole and how it is used to measure the very tiny to measure the amount of very tiny particles like atoms, ions, or molecules. Remember the number of 6.022 multiplied by 10 to the power 23 is very important number for us in our calculation in the chemistry. Now we will discuss another concept which is called molar mass. How to calculate the molar mass
That's right
in
below the
simple
element symbols.
way.
Think of the time. How to calculate molar mass in 3 easy steps. First off, there are many other names for molar mass. They all tell us the mass of 1 mole of a given compound. The key is to find the atomic mass for elements, and that's right below the element symbols. Think of atomic mass as molar mass for an element. Let's find the molar mass for carbon monoxide. So we go to the periodic table, we find carbon, and we find oxygen, and we see the atomic mass there right below the element symbol. To find the molar mass, we add those two numbers together, and we add the units, gram per mole, and we're done. We've found the molar mass. You may have noticed that in the previous example, I rounded to 2 decimal places. Make sure you know what your teacher requires. Let's do an example, H2O. You can think of H2O as being made up of 2 hydrogen atoms and 1 oxygen atom. So we can go to the periodic table, find the atomic mass for hydrogen, and then for oxygen, and then we'll add the 2 hydrogens plus 1 oxygen to find the molar mass for H2O. But there's a quicker and easier way to do this. We can write the atomic mass for hydrogen and multiply that by 2, and then add the atomic mass for oxygen. And that'll give us the molar mass for H2O. Let's try another, NH3. So first, we look up the atomic masses on the periodic table. We have 14.01 for nitrogen and 1.01 for hydrogen. And then we're going to multiply that hydrogen by 3 because there's a subscript of 3 after the H. Once we do that, we add everything up and we have the molar mass for NH3. Pause and try these on your own. So check your work and make sure you included the units grams per mole. Just to mess with you, I included parentheses in the third one. So how do we deal with this when we have parentheses? We'll use the same process as we've been using. So first, I'll write down the atomic mass for each of the elements. And then I'll put the parentheses around the elements just like they show up in the formula. And because I have this 2 right here, I'm going to multiply everything by 2. Once I do that, I then have 40.08 plus 17.01 times 2, and then I'll just add these two numbers together to get the molar mass for calcium hydroxide, CaOH2. So pause and give these two a try. So check your work. If you're having problems, in the description there are links to full videos for each one of these compounds. There's one more type of molar mass we need to learn to calculate, and that's for what's called a hydrate. This is copper 2 sulfate pentahydrate. Penta means 5, and the little dot means those 5 water molecules are around the copper. To calculate the molar mass, we'll first find the molar mass of the copper sulfate, and then we'll find the mass of the water. Once we have those, we'll add the copper sulfate to 5 times the mass of the water molecule. That's because we have 5 water molecules. We add this all together, and that's the molar mass for copper 2 sulfate pentahydrate. Pause and try this one. So check your work. If you had problems, look in the description. There are more videos, including one on MgSO4 heptahydrate. This is Dr. B with Molar Mass, and thanks for watching.
This is an important video for important calculations in our study, how to calculate the molar mass of different chemical compounds. This is very important process. We must be perfect in these calculations. Up till now we finish our lesson for this week. I hope to be easy and practice more and more to be perfect in these qualifications, in these calculations and these skills, which is important for the study of chemistry in this year and the next year, inshallah. Thank you for your attention. Goodbye.